What happens if you fall into a black hole, the journey no one returns from? Imagine this. You're floating in the emptiness of space. No sound, no air rushing past your helmet, just the quiet hum of your breathing and the steady thud of your heartbeat echoing in your ears. And then you see it, a darkness ahead of you. Not the ordinary blackness of space dotted with stars, but something different, something wrong. A perfect sphere of absolute nothing that seems to devour the light around it, bending and twisting the stars into impossible shapes. You try to turn away, you fire your thrusters, but nothing works. The pull is too strong. You're falling, and there's no way back. This is what we're going to talk about today. What happens if you fall into a black hole? The most terrifying, most fascinating, most mind-bending journey in the entire universe. A journey that would tear apart everything you think you know about space, time, and reality itself. I'm going to take you through it step by step. What you would see, what you would feel, and what would happen to you in those final moments before everything ends. And I want you to come with me on this journey, because here's the thing. This isn't just some abstract science lesson. This is personal. If somehow, impossibly, you found yourself in this situation, this is exactly what you would experience. Now look, I know what you're thinking. It's impossible to fall into a black hole, right? We're safe here on Earth, millions of light years away from the nearest one. And you're absolutely right. The chances of this actually happening to you are basically zero. But here's what I want you to understand. We're going to do this together anyway, because sometimes the most incredible things in science, the things that teach us the most about our universe, are the things that seem the most impossible. So let's say, just for the next few minutes, that somehow you did fall into a black hole. Maybe you're an astronaut on a mission that went terribly wrong. Maybe you got too close without realizing. Maybe you're just incredibly unlucky. It doesn't matter how it happened. What matters is that it's happening. And I'm here with you, explaining what's going on, because nobody should have to face the unknown alone, even in a thought experiment. So take my hand, friend. Let's find out together what happens when you fall into the darkest place in the universe. First, let's talk about what a black hole actually is, because that's going to help you understand what's about to happen to you. A black hole is a region of space where gravity has become so incredibly strong that nothing, not even light itself, can escape. It forms when a massive star, something maybe 20 or 30 times the mass of our sun, runs out of fuel and collapses in on itself. All that mass gets compressed down into an impossibly small point called a singularity. And around that singularity is an invisible boundary called the event horizon. Cross that line and you're done. There's no coming back. Ever. Now here's the thing that most people don't understand about black holes. They're not cosmic vacuum cleaners. They don't suck things in like some kind of space drain. If our sun suddenly turned into a black hole right now, which it can't because it's not massive enough, but if it did, Earth would just keep orbiting at the same distance. Nothing would change. The gravity would be exactly the same. Black holes only become dangerous when you get close, really close. Close enough that the gravitational pull becomes so intense that the difference between the gravity at your feet and the gravity at your head becomes significant. And that's where your problems begin. Let's say you're approaching a stellar mass black hole, one that formed from a dead star, about 10 times the mass of our sun. You're still pretty far away, maybe a few 100,000 miles. At this distance, you might not even realize what you're looking at. Space around you looks relatively normal, stars shining in every direction. But then you notice something strange. There's a region ahead where the stars seem to be bending. Their light is curving around an invisible sphere, creating multiple images, distorting the sky into impossible patterns. That's the black hole's gravity warping the fabric of space itself, bending the path of light like a lens. And as you get closer, that distortion gets more and more extreme. The stars behind the black hole start to compress into a bright ring around the edge of the darkness. Light from every direction is being pulled around the event horizon, concentrated into a glowing halo that gets brighter and brighter as you approach. Color shift. The light in front of you gets blue shifted, appearing more blue and violet as you accelerate toward it. The light behind you gets red shifted, stretching into deeper and deeper reds. You're starting to move fast now, really fast, thousands of miles per second, and there's nothing you can do to stop it. And then the pain begins. You see, a black hole doesn't kill you gently. It kills you through a process that scientists have given the darkly humorous name of spaghettification. The term was popularized by Stephen Hawking, who described the fictional astronaut being stretched like spaghetti as they fell into a black hole. And that's exactly what's happening to you right now. The gravity at your feet, the part of you closest to the black hole, is pulling harder than the gravity at your head. Much harder. And that difference creates what's called a tidal force, the same kind of force that causes ocean tides on Earth, except millions of times stronger. Your body starts to stretch. At first, you might not even notice a slight pulling sensation in your legs, a tightness in your chest. But it gets worse, fast. The bones in your legs begin to separate, your spine elongates, your skin stretches tighter and tighter, and then you start to be compressed from the sides. Just as you're being pulled lengthwise, you're also being squeezed horizontally. Your shoulders crush inward, your ribcage compresses. You're being transformed from a human being into a long, thin strand, like pasta being pulled through a press. Spaghettification. For a small black hole, this happens long before you even reach the event horizon. The tidal forces are so extreme at distances of hundreds of miles that your body would be torn apart molecule by molecule, atom by atom, while you're still technically outside the black hole. You wouldn't survive to see what's inside. But here's where it gets interesting. If you were falling into a supermassive black hole, one of the giants that sit at the centers of galaxies, millions or even billions of times more massive than the sun, the story would be different. These monsters are so large that their event horizons can be as wide as our entire solar system. And because the tidal forces decrease with size, you could actually cross the event horizon alive. You wouldn't feel anything special as you pass through. No barrier, no sudden change, just a gentle crossing of an invisible line. But the moment you do, your fate is sealed. There is no escape, not with rockets, not with magic, not even theoretically. You are now inside a region of space where every path, every possible future lead to the singularity at the center. It's not just that you can't escape, it's that escape has literally ceased to be a concept that applies to you. You are falling toward the center the same way you're moving forward in time. It's inevitable. And here's where time gets really weird. Because what you experience inside the black hole is completely different from what someone outside would see. Let's say you have a friend watching from a safe distance in a spaceship. As you approach the event horizon, they would see something bizarre happen. You would appear to slow down. Your movements would become sluggish. The light reflecting off your spacesuit would shift toward red, getting dimmer and dimmer. And as you reach the event horizon, you would appear to freeze completely. Time, from their perspective, would stop. They would never see you cross the boundary. You would just hang there, frozen at the edge of the darkness, gradually fading from view as the light stretched into longer and longer wavelengths, until you disappeared entirely. According to them, you never fell in. You're still there, forever frozen at the edge. But that's not what you experience. For you, time keeps flowing normally. You cross the event horizon in seconds, maybe less, and you keep falling. Inside the event horizon, space and time swap roles in a way that's almost impossible to describe. The direction toward the singularity is no longer a direction in space, it's a direction in time, the future. Moving toward the center isn't like walking toward a destination, it's like moving from Monday to Tuesday. You can't stop it, you can't turn around. Time only flows one way, and that way leads to the singularity. As you fall deeper, the tidal forces intensify. Even in a supermassive black hole, there's a limit to how far you can go before spaghettification catches up with you. Your body stretches more and more, your vision distorts. The universe behind you compresses into a shrinking circle of light. Everything ahead is darkness. And then, if the black hole is rotating, and most of them are, things get even stranger. You might start to see multiple copies of that circle of light, reflections of photons that have orbited around the black hole multiple times before reaching your eyes. The laws of physics start to break down. Space becomes a twisted maze where light travels in spirals and loops. And then you reach a region that physicists call the inner horizon. This is where quantum effects that we don't fully understand start to matter.
Some theories suggest that at the inner horizon, you would experience a phenomenon called mass inflation, where the energy of Hawking radiation, those quantum particles created at the event horizon, gets amplified to infinite levels. You would be hit by a wall of radiation so intense it would vaporize you instantly. Other theories suggest the spacetime itself becomes unstable, churning and mixing in what's called mixed-master dynamics, tearing apart anything that enters with rapidly oscillating tidal forces that change direction chaotically. First you're stretched, then you're compressed, then stretched again, over and over, faster and faster, until there's nothing left of you but a cloud of subatomic particles. But let's say somehow you survive even that. Let's say you make it all the way to the singularity. What would you find there? Honestly, we don't know. Our physics breaks down. The equations of general relativity predict a point of infinite density, where all the mass of the black hole is compressed into a space with literally zero volume, a mathematical impossibility. Infinity is not something that exists in the real world. It's a sign that our theories are incomplete. Some physicists think the singularity might be a gateway to another universe, a white hole on the other side, spewing out matter. Others think it might be a region of quantum foam, where space and time dissolve into a probabilistic haze, governed by laws we haven't discovered yet. And some think it's just the end, a place where matter ceases to exist in any meaningful way, crushed out of reality by forces beyond comprehension. The truth is, no human will ever know. Because even if you could somehow communicate what you saw at the singularity, that information could never escape the event horizon. It would be trapped in sight forever, along with you. Every secret the black hole has ever consumed, every star, every planet, every spacecraft that ever fell in, their information lost to the universe. At least, that's what we thought, until Stephen Hawking discovered that black holes aren't completely black. They emit radiation, Hawking radiation, particles and antiparticles that pop into existence at the event horizon, with one falling in and the other escaping, making the black hole slowly evaporate over trillions upon trillions of years. When the black hole finally dies, what happens to the information about everything that fell in? Does it get released in the Hawking radiation, encoded in subtle correlations we can't yet measure? Or is it destroyed forever, violating the laws of quantum mechanics? That's called the black hole information paradox, and it's one of the biggest unsolved problems in physics. But you won't be around to see it. Your journey ends long before then. In those final moments, as you approach the singularity, time itself might do something impossible. Some solutions to Einstein's equations suggest that inside a rotating black hole, you could encounter regions where time becomes space-like and space becomes time-like, where you could, theoretically, move backward in time or sideways through dimensions that don't exist in our normal universe. You might see the entire future history of the universe play out above you in a fraction of a second. Or you might see nothing at all, just darkness, and then oblivion. So here's what I want you to take away from this. Falling into a black hole would be the single most extreme experience possible in our universe. It would challenge everything you understand about reality. Time would stop making sense. Space would twist into impossible shapes. Your body would be torn apart by forces so strong they make nuclear bombs look gentle. And at the end, you would encounter a place where the laws of physics themselves break down, where our best theories can only shrug and admit they don't know what happens next. But here's the beautiful thing, the terrifying thing, the thing that makes black holes so important to science: they're real. They exist. Right now, in the center of our own Milky Way galaxy, there's a supermassive black hole called Sagittarius A star, 4 million times the mass of the Sun. We've taken pictures of it. We've watched stars orbit around it at thousands of miles per second. And there are billions more black holes scattered throughout the universe, the remnants of dead stars and the anchors of galaxies, shaping the cosmos on the largest scales imaginable. And we still don't fully understand them. We don't know what's inside. We don't know if information is preserved or destroyed. We don't know if they connect to other universes or if they're just cosmic dead ends. Black holes are a reminder that the universe is stranger, more violent, more wonderful than we ever imagined. They're places where the rules change, where the impossible becomes real, where a journey that takes seconds for you can last forever for someone watching, where dying doesn't just mean the end of your life, but the end of your existence in any recognizable form. That's what happens if you fall into a black hole, my friend. You become part of the mystery, part of the darkness, part of something so profound that physics itself can't explain it. And maybe, in some strange way, that's beautiful, because it means there's still so much left to discover, so many questions left to answer. The universe hasn't given up all its secrets yet, and as long as black holes exist, as long as there are places in the cosmos where our understanding fails and the rules break down, there will always be something left to wonder about, something left to explore, even if only in our minds. So the next time you look up at the night sky, remember, out there in the darkness, invisible and silent, there are places where reality ends, places where you could fall forever in a moment, places that would tear you apart and crush you into nothing while making you a part of something eternal. Black holes, the final frontier, the ultimate mystery. And now you know what would happen if you fell into one. I hope you never have to find out for real, but I'm glad we took this journey together.